It's very important to our school and to our programming that we not just be placed in the community, but be of the community as well.
We would not be successful as a medical school if we don't have an impact in this community.
From the beginning, Cooper Medical School of Rowan University set out to serve as a valuable resource for Camden and be a part of the community in which it resides.
Service learning is really important to CMSRU. It's so important that we felt that it needed to be a part of the curriculum, not something that was just elective.
It stays with you, like you think about the people that you helped here, and that's true whether you're helping at a school or whether you're in the student clinic or whether you're growing food in a garden, that what we've done here is really more impactful to the community and longer lasting.
The ambulatory clerkship is a program that lets us as medical students be the primary care physicians for real patients. And it also helps the community because it's a free clinic for people who don't have insurance.
Voice is a group to help the homeless veterans as well as educate our peers about military affairs and veterans affairs.
So Street Medicine is a program that we started in an effort to reach out to the homeless populations of Camden and provide basic services to them, whether it be healthcare, whether it be access to social services, or just someone to listen to, someone to talk to, someone to treat them like a human being.
Our community engagement focus differentiates CMSRU from other medical schools. By making service learning part of the curriculum, we're not only giving back to the city in which we reside, but we're also instilling an ethos of service to a new generation of physicians who will take that commitment to service with them and spread it around the country and the world.
CMSRU is special in the sense that we have, as part of our curriculum, a program where we actually reach out to the people of Camden to give back to their community. So Street Medicine is a program that we started in an effort to reach out to the homeless populations of Camden and provide basic services to them, whether it be healthcare, whether it be access to social services, or just someone to listen to, someone to talk to, someone to treat them like a human being. So we bring socks, we bring waters, we bring little bits of food, ways that we can connect with them and show them that we really care about what their basic needs are, and then have them open up so that they can talk to us about what their medical needs are or what other needs they have.
So one of the locations that we go to, there are a few people there that we've seen for at least 4 years. So we're gonna go check up on them today. If we see someone who has an issue that we can handle on the spot, we'll do that. We'll clean wounds, and if there's something more emergent, we tell people to go to the hospital. In worst case scenario, we'll call an ambulance. We want people to get to their appointments. And so every appointment that we've made so far for a patient, we have picked them up and we have taken them there and we have waited. And those are some of the best experiences that I've had. It makes them feel more comfortable because this is new to them. We have patients who haven't gotten medical care for, 20 years. And so it definitely helps for them to have a friendly face there with them, and we'll sit and explain things to them. I think it's really helpful for them to understand what's going on with their own body. You just learn so much about the complexity of healthcare, especially in a setting with so many issues like addiction and poverty and, all those kinds of things.
I've been homeless out here for going on 9 years. I've been through it all. You're helping people. You've helped a lot of people out here who wouldn't go to the hospital. Them coming out actually helped a lot of people who were sick. They sat there, and people who had like little problems, they came out and fixed them.
The homeless communities in not just Camden, but around the world are incredibly overlooked, ignored. But sitting and talking to somebody living on the streets, trying to hear their story, treating them like they're a human being, I think goes a really long way towards their mental health, towards their trust in people in general, and the trust in the community.
I just knew this is where I needed to be. There was just something about the feel, the vibe, the energy, the people in general.
I really felt like this was a place that I really connected with, and when I left the interview that day, I was just like ecstatic. I could not have been happier.
I was definitely a little nervous, but I was mostly excited. It was going to be fun to be the guinea pigs.
I wanted to be in a place that really prioritized serving the community in which it was situated.
The mission of CMSRU fits me perfectly, and I literally think I woke up one morning and had that realization.
Every school has a mission. I don't know if every school lives their mission. This school definitely lives our mission, and I'm proud of that. I'm proud to have been part of that.
When I first came in, I didn't fully appreciate how much being a part of a community was an important part of being a doctor, and how being a better person would then make you a better doctor.
It stays with you, like you think about the people that you helped here, and that's true whether you're helping at a school or whether you're in the student clinic or whether you're growing food in a garden, that what we've done here is really more impactful to the community and longer lasting. And I think that's made me more aware of the types of activities that I'm involved in and how much of myself I put into them, because these people are taking what we did home with them and it's impacting their lives in a larger way.
I think there's an expectation with service learning sometimes that you're going to see bad things that need changing. And honestly, in soccer, I saw mostly wonderful things. It was soccer practice just like I had when I was a little kid running around.
And it gives you a good way to kind of get locked into the community. And there's a few people that, I've seen the parents outside of soccer, either in Camden, some of them even work in the hospital. And it's just kind of nice you have that extra connection. You really feel like much more part of the community.
Because of CMSRU, I'm definitely more interested in working with underprivileged population and just trying to make a difference and serve.
It's a blessing to have been able to just, again, be aware of what is going on and the things that just play a huge role in how patients are able to take care of themselves on a day-to-day basis that you would never know if you were just sitting in the office and learning medicine in isolation.
One of the most special experiences of CMSRU was having our student-run clinic. We started off with, one faculty advisor and a couple Robert Wood Johnson fourth-year students with some advice, and we built a whole clinic.
People love to go to the clinic and have their own patients, and I think that is truly special, and you're able to provide care to Camden residents very early on and really get entwined in their lives and learn about the city through a patient's perspective.
Kind of gives you an idea of what being a doctor is you depend on the rest of the team.
I will always remember my first patient. She's called me doctor since day one, whether or not, even though I told her that I was not a doctor.
So stepping into that role in the community felt natural, but it did not feel natural that suddenly I was being looked at as someone with some degree of knowledge and authority in medicine. It was more uncomfortable than I expected to have a patient come and say, "Here I am, help me out." And that was scary and a really huge honor at the same time.
Gary was my first patient, my first physical exam of my first year, first month of my first year. He had a lethal tumor growing in his throat, and he was just so happy that we were there for him, that we were there helping him understand what's going on with him, even though if understanding what was going on with him was that he was dying. He taught me what it's like to live in Camden, what it's like to have barriers to care, but what it's like to still be hopeful, be happy, and to live a great life. It wasn't a matter of me being there for Gary, it was a matter of Gary teaching me. And that, I think, is one of the things I'll carry forward from this point forward, for the rest of my life, honestly.
I think the biggest difference I notice is how we talk about patients, like how we discuss our days and how we discuss our encounters. Just overwhelmingly the discourse here hasn't been about complaining or wishing that they hadn't done this, but more like, that was really cool. I was really glad I was a part of that. They said something great, I saw something great, I learned something great.
I think being here has been a great experience because you get to see patients from all different walks of life. It feels very special to work with a community who's so needing of help, and it's a mutual relationship, because as you teach them and you help them, they also teach you. Those were my teachers, And I think that the community here really helped teach me a lot.
This whole thing has been like an alteration in my perspective. Like, I don't think I'd trade my experience here for anything in the world. I've really kind of matured as a person and seen a completely different side of life. I've become more appreciative of my own children. I very much well appreciate my wife, and the people in Camden provide that to me.
My training at CMSRU, and I think specifically CMSRU, living in Camden for 4 years, the community I'm in, and more than anything, my classmates have made me now motivated because I want to change the world. And I know that sounds cliche, but I think we can change the world. I think we're going to be great physicians, and I think Camden has taught us things. I think CMSRU has taught us things that are unique to us. And I think we're going to do a heck of a lot more than help people.
So the community garden is really great. We work with Ms. Sheila Roberts, who is this wonderful woman who is a community leader and has taken this plot of land in the Landing Square community and divided it up into little mini plots and invites members of the community to come in and plant their own vegetables, so that anyone who wants to really has the opportunity to plant their own crops and then come in, help weed and water them, and then once they've grown up, get fresh fruit and vegetables. Because one of the big problems in Camden is that there aren't any real grocery stores here, so that when people want to have access to fresh fruit and fresh produce, they don't really have that. And so the community garden is really great because it's right there for them.
The patient population of Cooper Rowan Clinic are uninsured Camden City residents. Medical students oftentimes do not get any type of patient exposure until their third year of medical school. But here we're giving students the chance to see patients right from their very first year of medical school.
As students, it teaches us to not only really look at things from the medication side of things, but to also consider how important lifestyle is in the management of those conditions.
Through interaction with pharmacy students and the social work students, the medical students are able to gain an understanding of healthcare as a collaborative effort.
We get to get our hands-on experience from the first year that we start.
You're very nervous your first time interacting with a patient, being in the clinic, having a patient or two under your care. It's made that patient interview much, much, much easier.
And the fact that we have those 2 years of experience before we transition over to the hospital just makes everything easier for the doctors that we work with in the hospital and also for ourselves and the patients.
And I feel much more prepared than I guess maybe some other medical schools that might not have gotten it from day one. It's made me more open-minded and definitely much more humble about what I have.
Something like that, yeah. I'm trying. 10!
My dreams came true all the way.
I'm Susanna.
And I'm Samantha.
We're from Camden.
And we're going to graduate Cooper Medical School of Rowan University.
We're extremely proud of Susanna and Samantha. And although they're not the first physicians to come from Camden, New Jersey, they are the first for this new medical school who are actually from the community. We've always wanted our school to be of the community, to be a resource, to be inspirational to young people from the community, and they fulfilled all those dreams.
From the beginning, CMSRU really recognized the importance of having diverse students in our population. They bring a different perspective, they bring different views. So even before we had our first group of medical students here, we actually had our first pipeline program, and that was really to stimulate the diversity of our student population. And that's where we really first met the twins in our college level Pulse program.
Before we entered the Pulse program, we were terrified to even think of becoming physicians. And once we were here, it gave us perspective that we were capable of doing this.
When they're aligning kind of all the puzzle pieces for you and you sense all the help, I think you become more inspired.
When there was the medical school developing in Camden, for us that was a sign that we were called to come back home and to pursue our studying here. And it was kind of like they were making a medical school for us.
The fact that it happened exactly when we were interested in going to medical school, it kind of seemed like fate.
We recognize that there are a lot of youth that are looking up at us now, and that we are no longer those teenagers looking for mentors and role models now.
Good morning. Welcome to Medical Education Grand Rounds. I'm Dr. Rose Kim, the Assistant Dean for Faculty Affairs. Thanks for joining us. We will be having coffee service, and so please help yourself. It should be coming out shortly. I do apologize for the delay. So we're honored to actually have two speakers today coming from different backgrounds, and I'm going to introduce both of our speakers. Our first speaker is Dr. Ken Lacovara. He's the founding dean of the School of Earth and Environment at Rowan University and a professor of paleontology and geology. He is also the founding director of the Gene and Rick Edelman Fossil Park in New Jersey. Dr. Lacovara received his bachelor's degree in geography at Rowan University. He then went on to receive his master's degree in coastal geomorphology at the University of Maryland, College Park, and then his PhD in geology from the University of Delaware. Prior to joining Rowan in 2015, Dr. Lacovara spent nearly 20 years as a professor of paleontology and geology at Drexel University. The scope of Dr. Lacovara's work in paleontology has included discovering some of the largest dinosaurs ever to walk the planet, including the supermassive Dreadnoughtus shrani in Patagonia, Argentina. In his quest to understand these titanic creatures, Dr. Lacovara blends exploration in remote locations across the globe with the latest imaging and modeling techniques from engineering to medicine. Dr. Lacovara has been widely recognized for his groundbreaking work in paleontology and geology. His TED Talk presentation, Hunting for Dinosaurs Showed Me Our Place in the Universe, was among the top 10 TED Talks of 2016. He has appeared in numerous television documentaries, and his discoveries have been reported in Discover and Time magazines. Dr. Lacovara was named by Men's Journal as one of the next generation of explorers. He is the recipient of the prestigious Explorers Club Medal, whose luminaries include Neil Armstrong, Jane Goodall, and Sir Edmund Hillary. He is also the author of the book Why Dinosaurs Matter, which takes readers on a deep dive into Earth history. Today we have the honor of having Dr. Lacovara speak on the topic of climate change. His talk is titled, What Does Deep Time Tell Us About Climate Change? Why Should We Worry? Our second speaker is Dr. Darilyn Moyer. Dr. Moyer is the Executive Vice President and Chief Executive Officer of the American College of Physicians. Dr. Moyer received her bachelor's degree in the biological basis of behavior, biology, and psychology from the University of Pennsylvania, and then she went on to attend medical school at Temple University School of Medicine. She then completed her internal medicine residency at Temple University Hospital, where she also served as chief resident and clinical instructor of medicine. She went on to complete an infectious disease fellowship at Harbor UCLA Medical Center. Prior to joining the leadership of the ACP, Dr. Moyer is a professor of medicine, executive vice chair for education in the Department of Medicine, internal medicine residency program director, and assistant dean for the graduate medical education at Lewis Katz School of Medicine at Temple. She was previously the co-faculty advisor for the Temple University School of Medicine Internal Medicine Interest Group and for the Student Educating About Healthcare Policy Group at Temple University Medical School. She received the Temple University School of Medicine Women in Medicine Mentoring Award in 2012. Dr. Moyer has served on the ACP's Board of Regents, which is the main policy-making body of the college. She has chaired the ACP's Board of Governors and has served as the governor of the ACP's Pennsylvania Southeastern Chapter. In 2016, Dr. Moyer was the chair of the Health and Public Policy Committee of the ACP. This committee was instrumental in developing the ACP position paper titled Climate Change and Health, a position paper of the American College of Physicians. Today, we have the honor of having Dr. Moyer speak on the topic of climate change in healthcare. Her talk is titled, Dear Earth, It's Not You, It's Us. Let's warmly welcome our speakers today.
Thank you, Rose. Thank you, everyone, for having me here. Thank you, Annette. It's a really wonderful space to speak in. And wow, it's early. This is definitely the earliest talk I've ever given. I think I can feel my telomeres shortening as I speak here, which the degradation of which is inversely correlated with sleep, which is positively correlated with life expectancy. So we're literally killing ourselves to be here this morning. But thank you. There's a little bit of overlap between vertebrate paleontology and medicine, and in fact, about a third of vertebrate paleontologists find their employment in medical schools. And you have one here, Ali, who teaches anatomy. Little bit, we work on a lot of species as well, so it's a little bit like veterinary medicine. Sometimes I say I'm like a veterinarian without the hope, you know. So climate change, it's a fact. People ask me sometimes, do you believe in climate change? No, I don't believe in climate change. Climate change is not a belief system. Climate change does not require my belief any more than gravity requires my belief. Scientists have gotten pretty good at taking the temperature of things over the last 500 years, and it's an incontrovertible fact that the planet is warming. It's also a fact that humans are the cause of the warming because physics. We understand what happens when we use the atmosphere for our trash can. And when you do that, unless you're dumping inert gases into the atmosphere, there's going to be a physical reaction. And the reaction that we're experiencing is we're seeing the atmosphere of the Earth heat up in a very dramatic way. And so I just want to take you through some of the reasons why we know this is the case. So climate change is happening. Here's the increase in temperatures that we've seen in about the last 200 years. And so we can ask the question, what is causing this? Is it the planetary periodicities that the Earth goes through? There's three cycles called the Milankovitch cycles that have to do with the orbital mechanics of the Earth. There's a 22,000, a 44,000, and a 100,000 year roughly set of periods, and the summation of these signals affects the solar flux, the solar radiation that the Earth receives. And we know these periods quite precisely. In fact, they can change the climate in dramatic ways. When we have glacial and interglacial periods, these are largely forced by the Milankovitch cycles. So only about 18,000 years ago, there was a continental glacier that went from the North Pole, where it was over a mile thick, down all the way to New Brunswick, New Jersey, down to the Lehigh Valley in Pennsylvania. And this is because of variations in solar radiation. But this takes place over tens of thousands of years. If you look at just the last 200 years of industrialization, you can see that blue line there. It really has a negligible effect, right? It's just kind of noise around the mean. What about the sun? Well, we know the sun has solar cycles. It has a 22-year sunspot cycle, which affects the amount of solar radiation that we receive. The sun is also heating up very, very slowly over geological time, and in fact, 8 billion years from now, the sun will expand and engulf the Earth. Long before that, about 1.8 billion years from now, the sun will heat up so much that the Earth's oceans will boil. But that's an effect that takes place over really, really deep time. If we look at the effect of solar radiation changes in the last 200 years, negligible. What about volcanoes? We know that volcanoes spew large amounts of CO2 and other greenhouse gases into the atmosphere. And in fact, it's been volcanoes that have been responsible for 2 of the world's 5 previous mass extinctions defined as events in which over 75% of species go extinct. And the mass extinctions at the end of the Permian period, about 250 million years ago, when 95% of species died. Complex life on Earth almost went out of business 250 million years ago. That was because of volcanism in what is now Siberia. These giant fissures opened, and what are called the Siberian traps were in place there, and it polluted the Earth's atmosphere, and the place turned into essentially a hellhole. And most species couldn't hack that. Happened again at the end of the Triassic period, another mass extinction, and this is really the one that paved the way for the dinosaurs. The dinosaurs first evolved in the mid-Triassic with crocodiles and lots of other things, but they're small, little tiny creatures that could terrorize nothing bigger than a bug. And it's not until that Triassic mass extinction caused by volcanism that wiped out a lot of the crocodiles, really opening the door then for the dominance of dinosaurs during the Mesozoic. So we know that volcanoes can have a big effect on the climate, and you can see those 2 mass extinctions there. The Permian and Triassic ones are the response to volcanism. But over historical times in the last 200 years, it's negligible again. In fact, every year humans put about 100 times more greenhouse gases into the atmosphere than all the volcanoes in the world do. So again, this is something that doesn't operate over the lifetime of a civilization in any effective way. If we sum those 3 things, if we take all of the major natural forcing mechanisms, you can see they kind of cancel out. So that's not it. What about things that we are doing? What about deforestation? Well, it does 2 things. It subtracts the number of plants that can draw CO2 out of the atmosphere, but it does another thing, which is it also lightens up the land surface and causes the land surface to become more reflective, as you can see here. So those things can cut both ways, and if we look at deforestation, it's actually a little bit negative in the last 200 years. What about the ozone? Ozone can work as a greenhouse gas and can blanket the Earth's atmosphere, causing it to warm. And the effect of ozone has also been essentially negligible over the last 200 years. How about aerosols, particulate matter in the atmosphere? They reflect sunlight, and they can cause the planet to cool. And we can see that they have had a cooling effect over the last 200 years on the Earth's atmosphere. Some people think that maybe we are going to geoengineer our way out of this, and one of the solutions that people propose is that we put particulate matter in the atmosphere, in the upper atmosphere, to act as sort of mirrors in the top of the atmosphere, because it does have this effect. What about greenhouse gases like the CO2 that comes out of tailpipes of automobiles, or the methane that comes out of the tailpipes of cows? Yeah, that seems to be it, doesn't it? That is closely correlated with the temperature increase that we've seen. And if we sum all of those factors that we just took a look at, well, that's pretty much it. We really do understand what's causing the planet. It's not natural phenomena over the last 200 years. It's human activity. It's the greenhouse gases. It's us. So, can greenhouse gases really change a planet dramatically? Well, yeah, they can. So we've got this experiment going on where we have 3 roughly Earth-sized planets, and we put them at different distances from the sun and change the amount of CO2 in the atmosphere, and you can see the results. So Mars is a freezer, essentially, minus 80 degrees Fahrenheit, average global temperature. In my opinion, it's a fantasy that we're going to colonize Mars. Yeah, I think we're going to visit there, and I would love to visit there. I would actually love to personally visit there. But Mars is a horrible, horrible place. If you look at Antarctica, Antarctica is like tropical paradise compared to Mars. And we can't even really live in Antarctica. You know how many babies have ever been born in Antarctica? 11. I looked it up. So we don't have a breeding population of humans in Antarctica. There's only one species of vertebrates that has a breeding population in Antarctica, penguins, which are dinosaurs. Right? All birds are dinosaurs. So dinosaurs still are the only vertebrate animals that actually have a breeding population on every continent on the planet. So we can't really even hack it in Antarctica, and it has niceties like air and water, which Mars doesn't have. What if we have too much CO2? Well, then you have Venus, where the average daytime temperature is 864 degrees Fahrenheit. That is not a nice place. We have really bad pictures of Venus like this because every time us, or previously the Soviet Union, landed a spacecraft on Venus, it essentially melts. It doesn't last very long. So we don't get good images of Venus. It's a terrible, terrible place, and that's what happens with too much CO2. We have a nice planet. We have kind of just the right amount of CO2, average temperatures of about 58 degrees across the globe. Pretty nice place to be, but that can change. This is what we're doing to atmospheric CO2 levels right now. You can see they were hovering around 280 for most of civilization. And then the industrial era begins, and boom, this is what's known as the hockey stick chart, right? And so that is pretty dramatic. And 400 parts per million is something that hasn't been seen within the near-term geological record. If we look at the past, say, million years of glacial periods and interglacial periods, you can see the carbon, the greenhouse gases fluctuating in what track with the glacial and interglacial periods, and then look what's happening right now. It's just this incredible exponential increase. You have to go back 50 million years ago to find the last time when we have 400 parts per million in the atmosphere. And we just crossed 400 parts per million a couple years ago. So that is scary stuff. Now, if you read the Intergovernmental Panel on Climate Change, the UN's IPCC reports, their prediction is that by the year 2100, we will hit 1,000 parts per million. And they have different scenarios for what temperatures that will yield. And so the do nothing scenario is that, oh, wow, what did I do? Hey, look at that. Okay. So the top line there, I was looking for my laser pointer, but I'm just not going to touch any more buttons here. So the top line is if we do nothing about climate change. That's actually what we're doing right now. We're essentially doing nothing about climate change right now. We have the Paris Accords, which the United States pulled out of, as you know. But nobody's making their Paris Accord targets right now. So we're essentially doing nothing. And if we do that, the IPCC predicted response is that we increase global temperatures to about by about 4 degrees C by 2100, or 7 degrees Fahrenheit. Well, that sounds bad, right? In the this is the predicted response for the mid-latitude. So you know, every day being about 7 degrees Fahrenheit warmer, that's a pretty big change. But I'm not sure they have all their bases covered here. What geologists worry about is what we see in the fossil record. And there have been a number of studies out recently, including this one from last year, where people are looking at the Eocene thermal maximum, the Eocene optimal period as it's called, when we were over 1,000 parts per million in CO2, and the planet was very, very warm. This is the time about 50 million years ago. It's just after the extinction of the dinosaurs, which happened about 65 million years ago. And we paleontologists, we can reconstruct Earth's CO2 history by looking at plant leaves. And as I'm sure you know, plants breathe through their stomata, right? These cells underneath the leaves where they take in carbon dioxide and give off oxygen. And plants don't make more of these stoma than they need, right? That would be inefficient. So when there's a lot of CO2 in the atmosphere, they have fewer of them. And when there's not so much CO2 in the atmosphere, they make more, so they can breathe. So we know what this relationship is between the density of stomata and atmospheric CO2. We can do it experimentally. Plants will actually adapt on the fly to this. And so we can use fossil plant leaves to reconstruct the ancient history of CO2 in the atmosphere. And the last time we were at 1,000 parts per million at 50 million years ago, there were crocodiles and rainforests in the Arctic. That's shocking and worrying. Now, if we're headed for anywhere near that kind of response, is that an existential crisis for our species? Probably not. I don't think humans are going to go extinct. There's a whole lot of us. But is that an existential crisis for our lives? Yes, it is, our lifestyle. Because I'm not sure that if we have crocodiles and rainforests in the Arctic and large swaths of the low latitudes become uninhabitable, I'm not sure that economic systems and governmental systems and societal systems withstand that kind of disruption. It's hard to imagine. And we can see, you know, just with the relatively small amount of warming that we've had so far, things like this. Migration is positively correlated with increase in temperature in various areas. So we're already seeing the first waves of climate refugees. And can you imagine what that would be like if we're headed for rainforests in the Arctic, if we're past 1,000 parts per million? And so, you know, in the last year, the tone and the tenor of the conversations between scientists who study these type of things have really changed, and the kinds of papers that are coming out have really changed. And I think there's a growing consensus that it's actually worse than we thought and getting worse faster than we imagined. And we have papers like this. We explore the risk that self-reinforcing feedbacks could push the Earth system towards a planetary threshold that, if crossed, this is the scary part, if crossed, could prevent stabilization of the climate at intermediate temperature rises and cause continued warming on a hothouse Earth pathway, even as human emissions are reduced. So scientists are starting to worry about tipping points from which we cannot recover. Even if we start to reduce our emissions, we might not be able to recover from these tipping points. If you tip the Earth into a different system, it might not come back from that system within the lifetime of a civilization. In fact, you remember that chart that I showed you of the glacial periods and the interglacial periods? Scientists now think that Milankovitch forcing, that Earth orbital forcing, will be ineffective versus the amount of CO2 that we put into our atmosphere. So the next 100,000-year glacial cycle probably won't happen. We're probably going to miss the next glacial period because we have changed the Earth's climate so dramatically. So for those of us who study geology and paleontology, wherever we go, when you look at the rocks will talk back to you, right? The rocks will whisper to you if you learn their language. And what they say everywhere you go is this. They say, it didn't have to be this way. It didn't have to be this particular way. There are an infinite number of histories that we could have had, and therefore at any one moment there are an infinite number of futures that we could have. And when you look back at the fossil record, it's nothing but a record of contingency. This is contingent on this and this and this and a million other things that we don't even know about. And you change one little thing here and everything about the future changes. If you look at our present day Earth, there's lots of different Earths that it could be. It's been different Earths. If you look at the snowball Earth about 700 million years ago, the planet iced over from pole to pole. Ice everywhere. This is before complex life, which happened about 500 million years ago. So 700 million years ago, the planet ices over from pole to pole. And before that, that probably happened once or maybe 2 times before that. That's pretty dramatic change. When we were in the end of the Permian, when 95% of life went extinct, it was more like that dry roasted Earth there. So we can have rapid changes and dramatic changes in the way the planet responds. And you look at this. Anybody know what this picture is?
That's the foot of Earth from when the satellites that went to Saturn came around.
Yep. When the Voyager spacecraft left our solar system, Carl Sagan basically begged NASA, turn that camera around and take a picture of us. Take a portrait of the Earth. And this is a famous picture called the pale blue dot. And that little dot in there, which is about a pixel, that's where everybody you've ever heard of is from. That's where every historical event you've ever learned about occurred. That's where everybody you ever loved lived. And you look at that tiny little lifeboat in space, and you can begin to see how fragile this place is. If you look at the biosphere, which is just this little scum of life that surrounds our planet, well, it's basically confined. We could go up to the top of Mount Everest. We could go down to the bottom of the Marianas Trench. That's only 12 miles. The Earth is about 25,000 miles across in diameter. So that 12-mile biosphere, that's the equivalent of an eggshell to an egg. Except take that eggshell and take half away, and then take half away again, and then what's left, take another 40% away from that. That's the thickness of the biosphere to the Earth. It's not much, and it's easy to damage, and that's the only thing that protects us from the deadliness of space and the hellacious conditions below our feet. We're in this little tiny lifeboat all together, and we're polluting our lifeboat. We're ruining our lifeboat. It doesn't make any sense. We're going to be in this room for about an hour today together. This is the number of species that are going to go extinct while we're here today. This is a statistical model. Most of these species we probably haven't discovered yet. So things are going extinct in ways that we have trouble imagining. And you know, extinction, when an individual species goes extinct, there's no news headline, right? Because what's happening? Like take Felis margarita, the little sand cat that lives in the north part of the Sahara. We don't know how many of those there are left. It might be dozens, it might be 10, it might be 4. But when there's 4, pretty soon there's 2, and then there's 1 that someday just curls up and dies under a bush. And that's not really a news event. These things just kind of vanish from the planet, unseen, unheard from, unnoticed, but it's happening at a rapid rate. If we look back at the last 2 million years, we can see that the background rate of mammalian extinctions is very rare for a mammal species to go extinct. The background rate of mammalian species is about 9 per century. Well, now, in the last century, it's not 9. You have to add those to it, and those, and those. That's the rate of mammalian extinctions that's occurring now. And you can see that's a dramatic departure from the background rate of extinction. So we are now propagating the Earth's 6th mass extinction. And, you know, initially, people may get interested in this because we're interested in saving charismatic wildlife, right? Like pandas or other kind of furry, cuddly things. But it's more than that. None of us are photosynthetic. We all require other organisms to sustain ourselves. These other organisms provide the ecosystem services on which we depend. And so, we need these species that are going away, many of them, before they're discovered. This was recently in the New York Times. Now, we know numbers of large species pretty well, and so we just saw how many mammals went extinct in the last 200 years. These are the numbers that are threatened with extinction right now. 25% of mammal species, almost half of amphibians. Amphibians are having a really rough time. 13%, I've seen other studies that take it up to a quarter of bird species. And then this is a real murky area right here because we don't really know how many species there are in these areas. And so those percentages that you see there, like under crustaceans, 3%, that's that they've looked at 3% of crustacean species, not that 3% are going extinct, a lot more, as you see by the chart. Flowering plants, that's bad, right? Insects are having a crisis right now. We have probably lost more than half of individuals of insects since 1970. Since 1970, half of Earth's wildlife has disappeared. Not species, numbers of individuals. Half have disappeared. I know just anecdotally, when I started my career and working in places like Montana and Wyoming, you could barely see when you drove across Wyoming from one spot to another. By the time you got to your destination, your windshield would be completely covered with smashed grasshoppers. I drove through there last summer, not a single one on my windshield. And grasslands in particular are having a real insect crisis, largely because of agricultural pesticides. So climate change is your issue. And for all of you in the room, it's your number one issue. Now, you may have come into the room thinking that your number one issue was something that you care passionately about, and I applaud you for that. Maybe it was heart disease, maybe it was food security. It could be any number of things. But your issue, the thing that you're most passionate about, that doesn't get solved unless we solve this issue. Climate change and the degradation of our environment will make every other thing worse or unsolvable. Because you think about the social impact of these economic disruptions and these governmental disruptions and the public health effects of bad economies. There's a study out the last year that predicts when we're, by the time we get to 2100, we can expect about 10% of our GDP to be knocked off every year by the effects of climate change. Well, we're all old enough in this room to remember a few recessions in the past, right? And those are minor. They last for 12 months or 18 months, and they hurt, right? An 18-month recession hurts. Imagine if every year we're knocking 10% off of GDP, and imagine the public health effects of that. Everything gets worse when that happens. And we can see, this is the asteroid that took out the dinosaurs 65 million years ago. This thing, asteroids, they form at the same time that the solar system forms. So it's hanging out there for almost 4.5 billion years, just like the Earth and the other planets, and it's going around. And then, one day the orbits just line up and it hits the Earth. And the dinosaurs, which dominated Earth's terrestrial ecosystems for 165 million years, they go extinct in literally a day, except for birds. They survive. And 75% of other species go extinct as the result of this. Now, you go out to the asteroid belt a couple billion years ago, and you take a piece of popcorn and you hit the asteroid with it, and it misses the Earth by a wide margin. Those are the kinds of contingencies that Earth history is hung upon. And so, we're playing with fire here. We're kind of like, we're like on the Starship Enterprise, and it's a very powerful instrument, and we're pushing all the buttons and we're pulling all the levers, but we don't really know what most of them do. And now our species has become this planetary engineering entity, but we're doing it in accidental and unthought about ways. So, when you look back at the fossil record, you see that, we're all freaks of nature. The chance of any one species coming into existence is almost zero, but things will happen, so something's going to exist. And then the chance of our species is almost zero, and the chance of you as an individual is almost zero. So we're extremely fortunate to be here. And the more I look at the ancient record, the more gratitude I feel for being a member of a species that got to exist and for being an individual that is alive. But now we've become the asteroid of our age. And I think it's up to all of us, especially people like us in this room, people that have the means and the education to have a voice in this and to do something about it. I think we all need to take this upon ourselves as our issue so that we preserve as much as we can of what's left and make a better future for the rest of us. Thank you very much.
That was great. Thank you.
Dr. Moyer, thank you.
Good morning. Thank you so much for inviting me. And it's hard to follow a fabulous talk like that. And in full disclosure, since we have to do disclosures, I do not have a TED Talk. But I was asked here to talk a little bit about the health consequences of climate change, which again is not a belief system, it is a fact. And to also talk about the importance of advocacy in this arena. So I think that the case has been well stated for what is happening to this wonderful planet that we live on. We are slowly being boiled in a pot. And we've certainly seen a lot of compelling images of folks. There's a lot of effect that is broad-reaching and very subtle at times. One of the questions I get when we put policy papers out from the American College of Physicians is, Darilyn, why are we getting involved in social issues? And I have to talk to people because I still practice in North Philadelphia. I still see patients at Temple, where social determinants of health are critical to patient outcomes. In fact, by some estimates, over 50% of patient outcomes are due to social determinants of health. And there are certainly a lot of other issues that we need to step up and be engaged in because they have huge impact on our patients, our society. The other question I frequently get is, why is our medical professional organization so political? We're not political, okay? We are nonpartisan organizations. Fundamentally, we are about the effectiveness of healthcare. Unfortunately, because healthcare has been politicized in our country, we have to engage in the political environment. We've certainly seen the compelling pictures of the animals that have been affected by climate change. But we're here to talk really about the health and what's happening. And we're seeing more and more people exposed to the intense heat. I believe that September was the hottest month in the history of when we've been documenting that. You've heard Dr. Lacovara talk about what's happening with mass migration in the humans on our planet. And over 1 billion people are going to need to migrate within the 21st century due to the rising sea level. And there's a lot of data, if you want to look in the clinical medicine literature, about extreme heat research and what's happening with policy change. So there's a ton of data. I put some of the references in there for you. but I thought maybe what I would do is give you a little bit of information that will help you maybe take care of a patient and maybe answer a board question right, since we make you do that throughout the rest of your life. I'm a PGY 35, and I'm still taking standardized tests, but also hopefully get you excited about stepping up to advocacy and getting involved with groups of folks who amplify your singular voice, such as a professional medical organization. So heat-related effects, clinical presentation, mild symptoms, of course, heat exhaustion, and the thing we always are very concerned about with heat stroke. Really, lots of groups at risk. We know lots of physiologic changes in our aging patients that make them more susceptible to extremes of temperature. Folks that have problems with thermoregulation, children and older kids, sports enthusiasts, right? The weekend warriors and all those folks. Laborers, we recently had a resolution in our Board of Governors at the ACP about having specific policy around the heat-related effects for laborers. Homeless folks, a huge impact on them. Of course, the social determinants of health, poverty and lack of air conditioning, the urban settings with pavement, lack of trees, the fact that some developments have been landlocked, exacerbating the pollution going into the atmosphere, which is triggering asthma, COPD, and allergies. Chronic conditions such as COPD and CHF. Mental health patients, where we know that a lot of the medications that we give our folks that have mental health challenges cause problems with thermoregulation. So lots of really serious projections about what's going to happen in mortality over the next century or so because of heat-related illness. This is actually a slide from the CDC that talks about the major categories in terms of climate change and human health. We're going to run through a few of those. We did give them some feedback that they didn't put Zika on there. They have malaria, dengue, encephalitis, and of course we've all heard about the migration of eastern equine encephalitis, which was typically found in the southeast portion of the US. We're now seeing cases reported in New England. Rift Valley fever, Lyme disease, chikungunya, West Nile virus, and of course Zika is the other one. The other infectious disease that we're seeing emerge that is becoming more common and in places we typically didn't see it is amoebic encephalitis, Naegleria fowleri. So lots of elements, aging population, chronic respiratory disease, asthma rates, etc., playing into this. So heat waves are an issue. I happen to be in Europe this year during the first heat wave in Europe, where it was 105 degrees in northern Italy. Lots of excessive deaths when we see our heat waves come through. But the future projections are really dismal and really frightening. 30,000 deaths per year in the US by the year 2100. We've got to get our act together. We've got to work together as communities. We've got to be better communicators. We've got to have good public health warning systems. We've got to be able to deploy temporary housing for vulnerable populations, and I would like that to be permanent housing, and I'm sure you would like that as well. We've got to educate the public about the risk of heat-related illness, and we've got to all work together as a community. So lots of respiratory effects, as we've seen across the world. Allergies and asthma also increase and are trending upward. 55% of US and European population are testing positive for allergies. Increased length of the pollen season. I have some seasonal allergies. It seemed like the season never ended this year. And then, of course, rains and floods lead to increased mold and fungal growth. And they cost a lot. And it's not just the financial dollar that's attached to it. It's the morbidity and mortality. Our goal is to keep people out of the hospital because we know the bad cascades that can happen to hospitalized patients. Infectious diseases, we're seeing the increased risk of malaria transmission. So the blue is no change and the light blue is decrease. And you can see for most areas of the world, the projections are abysmal in terms of the increasing risk of malaria. Indeed, deaths from vector-borne diseases we'll see tremendous escalation as well. And these diseases, in addition to malaria, are dengue, chikungunya, West Nile virus, Zika, I just mentioned Eastern equine encephalitis, leishmaniasis, and then tick-borne diseases. And remember, there's now 4 things, not 3 things you can get from, they don't call them deer ticks anymore because that's not politically correct. The deer felt bad that we called them the deer ticks. So I believe they're called the black-legged ticks. But it's Lyme disease, anaplasmosis, babesia, and Powassan virus, which is a virus that causes a polio-like syndrome in its victims. Waterborne diseases, of course, E. coli, the bloody diarrhea one, the O157H7, and some of the other variants, salmonella, leptospirosis. And guess what? You don't have to be braided by an oyster on the Gulf Coast anymore to get Vibrio vulnificus. You can now get it in Nova Scotia. So this is the organism that has a predilection, particularly for people with pre-existing liver disease. So the classic board question is, the person goes wading in the water, they have a slight abrasion, the next thing you know, they're in septic shock, and oh, by the way, they drink a lot, or they have hepatitis C. What's the disease? And the disease is likely to be Vibrio, and now you can get it up in Canada as well. So we're seeing the migration of lots of these diseases. Cryptosporidiosis is also increasing. That's the famous water park disease, Giardia, and Cyclospora as well. And we're seeing more and more viruses emerge as well in lots more epidemics and lots more infected people. Food security is also an issue, and water scarcity. We're going to see increased crop losses, decreased nutrient content, and the global climate change is going to decrease food production despite the significant increase in demand as our population goes up on our planet. So we can see there's a cycle here, and there's lots of things feeding into each other. We talked about the medical and physical health. We also have the mental health, and we know that adverse events have impact on the physical health as well. So lots of concerns. So the migration concern, the crisis in countries and states, the crisis between states, under and unemployment, and failures of governance. So the WHO predicts about 250,000 deaths from 2030 to 2050 from these diseases alone, and it will disproportionately affect folks that are at the extremes of age and poor individuals and those with chronic medical illnesses in our country. So yesterday I was down in Washington. The ACP has a council of subspecialty societies, and we were meeting with the big house of internal medicine. There's about 24 subspecialty societies in internal medicine. Internal medicine is actually the largest proportion of practicing doctors in the US. We're about 25% of the total doctors in the US. The ACP is the world's largest medical specialty society. We have about 159,000 members. About 40,000 of them are medical students. About 25,000 of them are internal medicine residents and fellows. And what we talked about were, if not us, who, and if not now, when. Some of you may have seen this article on the right from Wall Street Journal, written by a famous nephrologist named Stan Goldfarb, who used to be a medical education dean at Penn. He wrote this article, "Take 2 aspirin and call me by my pronouns," calling out medical education for educating students and trainees about things that they have no business of being educated about. In fact, in his first line, he called the American College Physicians out specifically about our paper on climate change. Now, the backlash he got for this was just incredible, and I was so proud to see our medical students and our practicing docs and the public standing up against this, because the premise of Dr. Goldfarb's hypothesis was that because we're teaching our med students about social issues, there's not enough room in their brains to teach them the hard science that they need to know. So if you want to do something interesting, how many of you know about the Goldfarb Challenge on Twitter? It was trending on Twitter a couple of weeks ago. So if you go onto Twitter, do hashtag the Goldfarb Challenge or Goldfarb Challenge, and you'll see, you really realize how funny and clever physicians are, because there are comments such as, well, as I was removing the bullet from the gunshot victim's chest in the emergency room, I suddenly forgot the 3rd step in the Krebs cycle. So it's really a fascinating diatribe. So climate change is here. It's already hurting your patients. We thought it was really important to step up. And so how this policy that we came up with in 2017 evolved was it was brought to the ACP by a resolution through our Board of Governors, by our New York chapter. It came up through our Board of Governors, was approved by the Board of Regents, and went to our Health and Public Policy Committee for a deep dive evidence-based review, which is how we create policy. We base it on evidence and science and not by polling people about their opinions on things. And our paper was released in 2017. We have a lot of recommendations in the paper. I'm not going to go through the paper. You can look at the paper on your own. But what I really wanted to talk about is the advocacy piece of this. You know, it seems like we're really busy taking care of sicker and sicker patients all the time. How can you possibly get involved and do more than you're already doing? Well, you're already advocating for your patients every day, trying to get them stable housing, trying to get their medications, trying to get them into a stable living situation. What I think is really important is that you amplify that voice. Our voice is collectively stronger when we work together in these arenas. In fact, we have a lot of resources for you, and I hope that you'll check them out. I hope you'll go to the ACP online website. Just Google ACP Climate Change Kit, and you'll find actually a climate change PowerPoint and lots of data regarding the effects in various sections in the United States. It goes through the different regional effects of climate change. I just put the slide up about what's happening in the Northeast, is that we're getting more and more heat waves. We're having this ridiculous amount of precipitation, although we're not Texas, where I think they got 43 inches of rain in a 2-day period recently with the remnants of one of the tropical storms. Greening your facilities, it's all our own obligation to push our facilities. I've been pushing my organization. We've got to walk the talk. So we need to get rid of our plastic water bottles, etc., that we're using for meetings in our facilities. So we're making sure that we sort of clean house and are addressing all of the positions that we're promoting in our paper. So there's lots of great things you can do, and this is all part of the climate change toolkit, so please check it out. I unfortunately did not get to bike here today. I came over from the northwest suburb of Philadelphia, but as much as possible, I try to, walk on my own 2 feet to get to places and minimize getting in the car and try to use mass transportation. In this climate change toolkit, we have green tips for small practices as well as larger organizations. So what if it's a big hoax and we create a better world for nothing? Well, we're going to get energy independence, preserve our rainforests, sustainability, greening of jobs, livable cities, renewable, clean water, air, healthy children, etc. What's so bad about that? So I'm just going to leave you with a video, but if you have not seen the book by Zane Cowie, who is the 9-year-old who is imploring the grown-ups in his life to do something about climate change, I urge that you read it. I'm going to leave you with Greta Thunberg's compelling testimony at the UN.
My message is that we'll be watching you. This is all wrong. I shouldn't be up here. I should be back in school on the other side of the ocean. Yet you all come to us young people for hope. How dare you? You have stolen my dreams and my childhood with your empty words, and yet I'm one of the lucky ones. People are suffering. People are dying. Entire ecosystems are collapsing. We are in the beginning of a mass extinction, and all you can talk about is money and fairy tales of eternal economic growth. How dare you? For more than 30 years, the science has been crystal clear. How dare you continue to look away and come here saying that you're doing enough when the politics and solutions needed are still nowhere in sight? You say you hear us and that you understand the urgency. But no matter how sad and angry I am, I do not want to believe that. Because if you really understood the situation and still kept on failing to act, then you would be evil, and that I refuse to believe.
So in the interest of time, because I know you're probably all going to go take care of patients,
possible chain reactions beyond human.
Let's see. All right. I just wanted to leave you with just a few thoughts. Again, if not now, when are we going to do this? I think we heard the compelling case for why it's urgent that we act now. And if not us, who? So think about what you do every day in the course of your life, what you can do to impact your patients, and think about what you can do collectively by joining an organization that has a collective voice in this. So thank you for your attention, and I'm here. I can stay for a little while if anybody has questions. Thanks so much.
If you have any questions for our speakers, feel free to come up and engage them in conversation. Thank you.